right, so today we're going to continue on designing and implementing this array-based list for integers. Remember that we're gonna follow this process of designing the interface first before we even touch the implementation. And before we even do that, though, we're also going to design some ad hoc tests. Now, normally, if this were a real project, I would actually create a JUnit test suite and go with that. But we're just going to do ad hoc testing. All right. That's not the end of the story, right? When we design that interface, we're not necessarily going to get it perfect. When we design those tests, we're not necessarily going to get that perfect, and we're certainly not going to get the implementation perfect. Instead, this is going to be a feedback loop. Let's worry about the interface first, but then understand that eventually when we have an error or something like that, we'll go ahead and come back and fix it and add to that interface. We'll add to the tests and augment those tests. We'll add to the implementation and fix the implementation. Just to remind ourselves of what we were doing beforehand, we've got this constructor here that creates an array with an initial capacity. That default capacity is going to be 10. So remember that it can hold 10 elements, but the initial size is 0 because it doesn't have anything in it until we call this method down here, add. We also realized that, hey, it might be useful to have another add method. Just making sure the audio works. Yep. Another add method that was an index-based one. That index-based one is going to insert it, be able to insert it anywhere. Right? And then we also have this get method because remember CRUD, create, retrieve, update, and destroy. We want to be able to retrieve an element at a particular index. Okay. Now let's go ahead and complete the interface before we move on to the actual testing. Let's add a method to update elements. All right, public. I don't know what the return type here is going to be, but I'll go ahead and call it replace because I want to take 5 and I want to replace it with 2 or something. So index, it's also going to be index-based, int index, and int element x. Right? That's the behavior that's what I want to do. Let's go ahead and document that is what I'm trying to say. All right? So replaces the element at the given index, code index. Oh, note here that I've switched over to the JavaDoc style of doing code instead of the HTML style of doing code. So just be consistent one way or the other. I'll go ahead and go with the JavaDoc style. And remember what that does is if you hover over this, it'll typeset it in monotype font, which offsets it from the rest of it so you know that it's code. Right? Replaces the element at the given index with the given element code x there. Right. Well, what should my return type be here? What would be useful if you want to use this? Again, we're designing the interface here. How would you eventually want to use this? Here's 5, or here's 2. I want you to replace that element over there at index 5 with it. Well, what happens to this element over here at index 5? Just gets thrown away? Or we could return it. Right? That looks nice. Now, to do add a method to remove elements. Okay, public. Probably want to return that too. Right? Int remove, int index. Right? So what is that going to end up doing? That's going to end up removing, removes, and returns the element at the given index. Right? There. All right. I've got my interface done, at least my initial interface, my draft of the interface. Again, this is why we whiteboard things. Instead of doing it like this, I would have written out on a whiteboard, I want this method and I want it to do this stuff. I want this method and I want it to do this stuff. And then, of course, you could do it directly by writing the function's signature and then also the documentation. Generally, the documentation should come first. Documentation shouldn't be an afterthought unless it's truly trivial, right? Like all of these classes or something, right? I want to make sure that simply just by writing the documentation, it gives you an outline for what you need to do to implement that function, right? Yeah.
Would it be possible to implement the remove function inside of the replace function in this case?
Oh, what do you mean by that?
For example, to replace a given element, would it be possible to remove the element you want to replace from like insert another one?
I agree that replacing is a remove and a replace, right? So update, it would be like deleting it and then reinserting a new value. Yeah, we could probably look for optimizations like that, right? Apply that logic up here, right? Immediately. Add and add, right? One of them is more general and the other is more specific. This one's general in that you can add it to any index whatsoever. This one, however, is adding it to the end of the list. Right? Do we have to write both of these functions? Fully, that is? Probably not. Since this one is more specific, I'll call the more general one down here. Suppose that we've already done that. Right? Suppose that we've already implemented this function somehow down here. How would I go about adding it to the end? This dot add x, but to what index? Question mark, question mark. So let's start whiteboarding this kind of stuff. 10, 20, 30, and 40. Suppose my list looked like that. What's the size of this list? 4. Adding it to the end, indices 1, 0, 1, 2, and 3. Adding it to the end would be adding it at index 4. So in other words, add it where? In general? At the size. So this dot size. Right? If you actually look at the array list implementation, most of these functions aren't implemented. They're calling other functions. And then you implement the one general function to get everything done. Right? Again, you want to reduce failure points. Right? If this function calls this function, right, then the real work is done down here instead of repeating that work up here and down here eventually. Right? I only have one failure point. Right? This is kind of a failure point, but it's simple enough that it's not. Right? Okay. Now I am good with this interface here, even though I just jumped the gun and started doing the implementation. Let's come over here to my demo class and let's write some tests. So first of all, I need an instance of this thing to play around with. Right? List is equal to new. Oops. New. There we go. And then I can start adding things. List.add 10. List.add 20, 30. Right. There we go. And of course I would want to pull those out. So system.out.println list.get 0. What am I going to expect here? 10. Why? Because I'm going 10, 20, and 30. I'm always adding to the end. 10, 20, and 30 is what I expect. If I go 0, 1, and 2. All right. Obviously, it's not going to work because it's not compiled yet. This is a rudimentary test. Again, if I were doing this in a real system for a real project or something like that, I would not be doing ad hoc testing like this. I would be putting these things into a JUnit tester where I added 10, 20, and 30. And then I would expect that if I got the first one, it's 10. And if it's not equal to 10, I'll fail the test. If it's not equal to 20, the test fails. If it's not equal to 30, the test fails. Okay? All right, so we need to implement this, and we need to implement this minimally in order to get those tests to start running. I'm going to go ahead and get rid of those for now, just so that I can, test it as I go along. When we need to get stuff in there first, ideas. I'm going to backtrack here a little bit, because that seems like too much to think about at once. Let's think about just adding it at the end. Well, if I use that kind of code, what would it look like? This dot array sub this dot size is equal to x. Right? Is it that simple? Let's find out. Is it that simple that return this dot array sub index? If it's that simple, then why the heck am I writing this class to begin with, right? All I'm doing is, generally, if you only have if you have a function with one line, why did you write that function, right? Now, 9 times out of 10, there's probably a good reason why you did that, right? But I don't see the good reason here yet, seemingly because this is so simple. Well, let's go to our tests. Does that work? 30, 0, 0. Nope, didn't work. What happened to 10? What happened to 20? Let's come back over here to my add method. This one. Right. Is it enough to put x in there? Let's walk through what's happening. Initially, it's an empty list. Oops. Now remember, it has a capacity for 10 elements. What am I doing? I'm adding it to the current size. Size is initially 0, right? I want to add 10 to the end. Where's that going to be? 10. Right. All right, now I add 20. Where do I add it? I add it at the size, which is still 0. Ah. So what ends up happening? I end up replacing that with 20. I add 30, which ends up getting that replaced with 30. Why? Because I never actually updated my size right there. All right, oops. So, what do I need to do? Once you add something, what else do you need to do? Update size, and just go plus plus. All right. If you remove something, what am I going to have to remember to do? Decrement it. Right. Let's try that again and see if it worked. Ah, good enough. Ship it. All right. Let's automate this a little bit more. Good code coverage. For int I equals 0, or let's say 10, I is less than or equal to 100, I plus equals 10. What I'm going to do is I'm going to add to the end I. 10, 20, 30, 40, 50, up to 100. Right? And I don't want to do this anymore. I want for int I equals 0, I is less than the list's size. Is there a way to do that yet? List dot size. Okay, I plus plus. And I will echo out what is at the ith index. And once again, I'm going to be expecting 10, 20, 30, 40, all the way up to 100. Oh, okay. I don't have size, do I? Let's go, because it's private. Is this the solution? Break encapsulation? No. All right. What should I do instead? If you want access to that thing, fine. Public int size. Return this dot size. I will do it through a getter here so that you can get a copy of that variable, because if I just made this into a public variable, you could do whatever you want with it. Right? You could decrement it, you could increase it, you could set it equal to 0. Right? You could go mucking with the internals of my class over here, and I don't want that. I want strong encapsulation. I want to protect my data by making it private. Now this is a function call, method call. All right, does it work? Ah, cool. I have even more assurance that it works. What else should I be testing? 110? Ah, index 10 out of bounds for length 10. Remember, how am I representing stuff? With an array. What is the initial capacity? 10. You can put 10, 20, 30, all the way up to 100, but what happens when you get to 110? You've reached your capacity. Okay? So let's come down here and fix that. If the capacity is reached, increase the capacity. Right. How do I know if the capacity is reached? Well, I only have size and array, right? So yeah, go ahead. This dot size, if it's equal to not just the default, because the default doesn't change, it's only 10, but if it has reached the size of the underlying array, this dot array dot length, right? They're 10, the length is 10. Now there are 10 elements in there. We need to increase the capacity. Right? Let's outline that. A, create a new array. Why do I create a new array? Because I can't change the other one. Right? Again, the whole reason for doing something like this is that arrays are bad. Once created, the size is fixed. It cannot be changed. Right? They can't grow, they can't shrink. That's why I'm doing a list data structure to do that for me. All right? So create a new array, copy a new array of larger size, right? Larger capacity, I should say. Right? Copy over the elements from ARR to this new array. And then finally, make this lists array point to the new array. And D, question mark, clean up the old array. Okay, yeah, go ahead.
When we do list that size plus plus increment by one, does that have any effects on the condition that we have for?
No, because this would have been, I mean, the condition comes first, right? So we check that before we get down here. We're going to increase the size. So if 10 and 10, it's already full, right? Then we're going to increase the size. We can still put something, now that the size has been increased as of line 41, we can add something and we can increment the size. Right? Okay. Create a new array. We know how to do that. Of larger capacity though. Int BR is equal to new int of the old one, or this dot array dot length, plus 1. Now it can hold 11 things, then 12 things, then 13 things. Right? Should I go in increments of 1? If I do that, imagine if this gets large enough. There are 10 million things in it. Just to hold one more element, are you going to copy over 10 million things? Right? That seems like a lot of work. All right, fine. Increase it to 10. Right. Maybe, okay, well, no, I find out that that's wrong too, so I'll increase it to 100. Right? Don't I have a variable to do that for me? Right? Now, if you're unsatisfied with that variable value, fine. Change the variable value. Don't hard code it somewhere else so that you have a default capacity of 1,000, right? Then it'll increase by 1,000, increase by 1,000. You can do some benchmarking to see what is the best optimal parameter here. I'll keep it at 10 for now. Right? All right, so it's larger because it's able to hold the old length plus a new default capacity. Copy over the elements for int, boring old for loop here. Int I is equal to 0, I is less than this dot array dot length, I plus plus, and BR sub I only did BR because B comes after A, right, is equal to ARR sub I. Right? If you want to call this new array, but I'm going to get rid of all this code here in a second anyway, show you something better. Right? Make the list, this dot array point to the new array. Right? Clean up the old array. If this were C, I would need to do this. Free old array. Right. Do we need to free anything over here in Java? Automated garbage collection. It'll take care of it for me. In fact, there's no way that I can actually do this at all. Right? Some auto garbage collected languages do allow you to explicitly collect the garbage immediately. PHP is one. Python, I don't think, allows you to do that. Maybe there is a way, maybe a lower level way of doing it, but nope, can't do that in Java at all. Right? There is no way that you can call a free on this. Now there is something called system.out.gc. Is it? There we go. GC, what do you think that stands for? Garbage collection, right? But when you read the documentation, it doesn't say what it does, right? In fact, it says, oh, you're putting in a request for garbage collection. But whether or not that request is honored is if I feel like it. I'm the Java virtual machine saying, if I feel like it. Now, it's got some very sophisticated algorithms here. And if it says the cost of garbage collection is greater than the benefit of reclaiming memory, it doesn't do it. Right? So it's a request, not an order. Right? It's treated as a request, not an order. Right? That's why you just generally don't do it. Right? Okay. Wow. Lots of code. 3 lines of code. Actually, 4 lines of code. Right? And a bunch of comments for it. Right? Don't do that. What's the first question you ask yourself as an engineer when you have a problem? Did somebody do this already? Right? Arrays dot copy of. There's a deep copy function here. This dot array, and it takes a second parameter. How big do you want the new copy to be? Right? This dot array dot length. That means that it'll be just a complete duplicate copy. 10 elements here, it copies over those 10 elements. If you subtract 5, it'll ignore the last 5 and only copy the first 5, right? Or the first length minus 5 of it. If you add 5, right, then that means it'll copy everything over and pad it out with 5 zeros, so that now you have your capacity. Right? I'm going to go with plus, what was it called? Default capacity. There we go. Right. And this dot array is equal to arrays.copy. There we go. One liner. Yeah.
Why don't you add only one to your list?
Why not just one?
Yeah.
So think about this when it gets really, really big. 10 million elements. Just to add one more means that you have to copy over 10 million things. Very, very expensive, right? But if you parameterize this and say, okay, well, that's really inefficient to make it to one, but it's a little bit less inefficient to make it to one. Oh, wow, we're getting even better performance here. But if we go too high, now the performance degrades because we are allocating way too much memory that never actually gets used. Right? That's something you can benchmark later on. I'm just going to keep it as 10 because I don't want to read 1,000 things, right? Also, I don't want to always, every time I add something, to automatically resize, right? I want a capacity there, okay? All right, that looks pretty good. Let's test it. Remember, it didn't work before because we reached the capacity. Now we're testing that add capacity, all right? We can bump this up to several orders of magnitude if we want now. And yep, it still works. Right. All right, let's kick it back down to 100 there. Actually, let's kick it down to 40. Right. 10, 20, 30, 40. Okay. All right, let's add something arbitrarily. Dot add element 42 to index, I don't know, 2. Right. What should that look like? Remember up here, it's going to be, before it's going to be 10, 20, 30, 40. All right. After, what should it look like if I'm adding it to index 2? That's index 0, 1, 2. So in other words, I need to shift everything down. I need to make sure that I'm giving myself enough room here in order to put in 42. So it should look like that at the end. Let's see if it works. 10, 20, 30, 40. No, why? Well, the reason is have I implemented that function yet? It doesn't do anything, right? Another trick here is always keep your to-dos, right? Implement. And in fact, you can enforce this a little bit more if you forget that there's a to-do there. You can always throw new unimplemented method. All right. Need to do your work. And unimplemented method exception, I think it is. There we go. And bring that in. There's something like that. I forget what it's called, but it'll throw this exception when you try to test it until you've actually implemented that method. Okay. Let's implement that method. So let's outline this. 1, what's the first thing I should think about? Capacity. Right? If the capacity is reached full, then increase capacity. Right? So code smell here. Cut, paste. If you find yourself cutting and pasting, are you doing something right? Maybe. Are you doing something wrong? Probably. Right? Even though this is only 2 lines of code here, right, I don't want to repeat it. I want to say public void increase capacity. And that's where I'll do that. So that I'm going to call that function instead of repeating that code. This dot. Now I can get rid of this. Now I can get rid of this. Oops, sorry. Right here. 3 lines code better than 5 lines code. Yeah.
Wouldn't you still need like the if statement before you increase the capacity?
That takes care of it down here, right? So let's document that. Increase, conditionally increases the capacity of this list if necessary. In other words, if it is full. Right. Yeah.
Does it need to be public?
Good observation there. Right. If it's public, list dot increase capacity. Does that sound right? That sounds like a leaky abstraction, right? In fact, what if I required you to do that? What if I didn't call that function at all? Instead, when you go to add something, oh, by the way, before you add it, call that function over there, right? So that you can't like, okay, before I add it, I'm going to increase the capacity. That sounds wrong, really wrong, right? What was the whole purpose of doing this? So that it automatically resizes, right? The class is responsible for taking care of itself. List things, or my integer array list things, belong where? In that class, including the logic to do that. So let's restore that, get rid of it here. But also, I really don't like that. It's part of the interface right now, right? Because what is the interface again? It is the public methods that you can use. Should we be allowed to use this? Probably not. So I'm going to make this into a private method, right? The class can use it. It is very useful because I don't want to repeat that code. But I don't want the outside world to use it. So I'm going to make it private. And that prevents you from doing this over here. Right? Okay. All right, that's the first step. Increasing the capacity if necessary. Right? What's the next step? This dot array of index is equal to x. What's it going to look like over here? Don't go to sleep. Needs to read my face. There we go. All right. So 10, 20, 30, 40. I want to add 42 to index 1. That means that I want to add 42 right here. Okay? Well, if I did that, what happens to 20 here? It gets overwritten with 42, the way that I'm doing it right now. What I want to do is I want to take these elements and I want to shift them so that there becomes room to put 42 here without losing anything else. Right? Visually, that's how it works. Now, how is that going to work programmatically? 10, 20, 30, 40. I want to insert it at index 1. Remember, these are indices 1, 2, 3, and 4. Or 0, 1, 2, 3, excuse me. Right? So I want to copy 20 over to 30. If I do that, what happened to 30? Gone. All right, so maybe I copy 30 over to 40 first. What happened to 40? Gone. So what I actually want to do is I want to start at the end here. I want to take 40 and shift it over so that it's over here. That leaves enough room that I can shift 30 over. Right? That leaves enough room so that I can shift 20 over. And that leaves enough room for 42. That's a simple for loop. Remember, I've already increased my capacity. Oh, wait, where are we? There we are. I've already increased my capacity. So I know that there's enough room to put that last element over, right? Okay? So for int I equals something, I is less than or equal to or something something, I plus plus, minus minus, I don't know yet, right? I'm going to shift things over, starting at dot 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 until you are at dot dot dot, right? Decrement or move left in the list, right? And copy over the ith element to the I plus 1 index, right? That's what I want to do. So where do I start? Where do I start over here? For this one example, 3. 0, 1, 2, 3. Yeah, this is 3. Sorry. So where am I going to start in general? Size. But the size here originally was 4, right? So size minus 1. Right? Size, this dot size. Get into the habit of doing it, even if you don't need to. Right? Question online. I saw Rust having to double the capacity of the string grows too large. Oh, good point. There are more sophisticated ways of doing this, and they're probably the default way of doing it in Java is probably more sophisticated than this. Instead of just adding a scalar value, you could of course say double the capacity times 2, right? That's actually done in TCP/IP as well. When you're sending something over a buggy network where packets can get dropped, you send only a certain amount of data. If that's successful, you double the amount of data the next time you send it. If that's successful, you double it again. You keep doubling it until it gets to a point where, oh, something got dropped. So you linearly fall back, right? Because you don't want to start over at the beginning. There's lots of theory and queuing theory and stuff like that that goes into this to make it way more sophisticated, but that's not the point of this, right? All right, so where were we? There we go. I'm going to start at the end while I is less than something. Remember, I'm going to go down. I'm going to decrement, move left in the list. Immediately, I'm going to go down by 1. Right? So while I is greater than or equal to something, right? Where do I end? At index. Because I still want to move the thing at index 1 over so that I can put something there. Copy over the ith element to the I plus 1th index. So this dot arrays of I plus 1 is going to be this dot arrays of I. There. Once you're confident that it works, you can go ahead and erase your notes and your outline and stuff. Right? Besides, that should be done on a whiteboard anyway. Right? All right. Am I forgetting anything? This dot size plus plus. All right. Now I can come back here and realize, wait a second. Do I really need to shift things down? No. This dot add, this dot array, this dot size, x. That takes care of everything for me. If you're adding it to the end, this for loop doesn't end up executing. But this line executes, this line executes, and this line executes, which is exactly what we just erased. Right. DRY, don't repeat yourself. See if it works now. There's 42, right in the middle where we wanted it. If I change it to 1, what would it look like? 42 right there. Hey, it works. What if I changed it to 0? Where would it look? Where would it go? Right at the beginning. That works as well. This is ad hoc testing, right? This is why I write JUnit tests, so that I don't change test, because I'm not done over here. I've got other things to do. And if I end up making changes, like for example, having this function call this function instead, I want to make sure that this stuff over here is repeatable. If I'm just ad hoc, willy-nilly, running this and changing it and running it again and changing it, right? Then these tests are not repeatable. JUnit is way better. Keep going. Ugh. What happens now? 42, whatever. That seems wrong. Right? If you want to take a Python approach, what would it end up doing? Wrapping around to the other side. I don't want to take a Python. This ain't Python. Right? When in Rome, do as Romans do. When in Python, do as Pythoners do. But when in Java, do as Java does. What's going to happen here? Predict. Out of bounds, index out of bounds exception, right? Okay. Array index out of bounds. I don't see an array here, do you? Leaky abstraction. I see a list. I don't see an array. Right? Why is it telling me about an array? Right? Yeah. So, the add method is public, but it's giving me a message that tells me something about the internal workings of the class. I don't want that to happen. I want to check for myself. If the index is negative, we will throw our own exception. Throw new, illegal argument exception. All right. Cannot have negative indices. All right, there we go. Now over here. There, that's much better. Illegal argument, it's not telling me that there's an array there, right? All I see is a list. Ignore that word for now. It's going to go away eventually, right? Cannot have negative indices. That makes sense, right? All right, fine. Don't have negative indices. Maybe I can go ahead and have large indices. Let's see, I've added 10, 20, 30, 40, 7. What would you expect here? Remember, it's 10, 20, 30, 40. So That's 0, 1, 2, 3, 4, 5, 6, 7. That's where I end up with 42. That seems wrong too. But in this case, it's not an error. But I don't get 42. I get 0. Why? We added it over here. We incremented the size, but we didn't add it where it should have been added. All right. Ideas. Would I equals index instead of I be more performant in Java? I have no idea. Handle the error differently. Yeah, that's what we're doing here. Sorry. I don't know if you're enrolled in this course or not, but certainly go ahead and continue chatting if you want to. All right. So illegal argument exception. Right? What happens if it's too big, like we've done over here? Right? I don't want gaps. So should we just say, okay, well, if index is greater than this, greater than or equal to this dot size, then what we'll say is, oh, you meant to add it to the end. So we'll just go ahead and say add, or this dot add x. There we go. And then return. Is that a good assumption? I'm not going to go about assuming things. I'm going to let you decide, right? I don't want to say, okay, well, they probably meant to do it like that, right? No, what I'm going to do is I'm going to throw it back at them, and then they can decide how to handle it. Throw, new, illegal argument exception, right? Indices cannot exceed the size, -1. Right. There we go. And now over here, I will get a proper error message. No, you can't do that. I could surround this with a try catch and then catch it and decide how to deal with it. No, okay, yeah, I did mean to end it to the end, add it to the end, right? But I'm not making, this list is not making that decision for me, right? Okay, that throws an exception. What about adding it to 4? That should still work, right? Wait. I should be able to add it to 0, 1, 2, 3, 4. What would that do? I'd just add it to the end, right? I do want to be able to do that. That makes sense, doesn't it? Right? So let's rethink this. If it's just simply greater than, right? So cannot exceed the size. Oops. Right, there we go. Because adding it at the end is just simply adding it at the end. Right? Okay, good. That's pretty good. Error checking first, making sure that you have enough capacity, making room for the element if necessary, and then, of course, increasing the size and putting the element where it needs to be. But that's got me thinking about this down here. What if I get something that I shouldn't be getting? For example, system.out.println get -1. System.out.println get list.size. Right? Those are two error, extremal error cases, corner cases, extreme cases. Right? They're on the endpoints, and that should result in some sort of an exception, just like this up here. Copy, paste. Not unless you have a really good reason to do so. I don't have a really good reason to do so here, but I do have a good reason to do so here because it's not the same logic. Right? If you ask for something, there are 4 elements in there, and you ask for what's that index for, that's beyond the bounds of what's in there. So you do have an argument for this one. You don't have necessarily an argument for this one. Right? Oops. Oops. No, come on. There's no redo there. Greater than or equal to. There we go. All right, and now when I run the tests, I get a illegal argument exception, cannot have negative indices. I would get the same on this one down here. So if I get rid of that and run that, I would get indices cannot exceed the size. Okay. All right. Meet or exceed. Meet or exceed. I guess that's a little bit better error message. All right. All right, I'm convinced that those things work. Now let's go on to replace. All right. replaces the element at the given index with the given element. Okay. What's the first thing I should be doing? Especially if I'm given an index. Copy, paste. Right. Icky, right? But we'll deal with it for now. Replace. Int temp is equal to this dot array of index. And this dot array of index is equal to x. Return temp. All I'm doing is temporarily saving this off so that I can return it down here. Because if I immediately just had this and only this, that old value is lost and gone forever. So I save it off into a variable so I can override it and then ultimately return it. Again, gross. Repeated. Right? Maybe it's something like private bound void bound check, right? Where I do of index int index. There we go. Why did I make this private again, by the way? Do you want the outside world to do bounds checking on your internal representation? No. Right? So bound check. Wonderful. Now I can replace this code with this dot bound check on index. And then I can also replace that code up there with bound check. Cool. Removes and return, and I haven't tested this stuff yet, but that's okay. We'll test it next time. Removes and returns the element at the given, didn't finish my thought there, at code index. Right, there we go. So the first thing I'm going to do is save it off. Int temp is equal to this dot array of index so that I can return temp. But really, what's the first thing I should have done? Bounds check. There we go. All right. Now let's outline the rest of this. We need to delete the element at index at index. Right. So free this array of index. That won't work. What if I said this dot array of index is equal to null? There are small I integers, so that wouldn't compile, but also conceptually it wouldn't work either because I still have a gap there. If I'm removing the element at the middle, then that's still a gap. What do I need to do visually? If I've got, say, 10, 20, 30, and 40, and I want to remove at index equals to 2. I want to remove this guy right here. Right? So what should it look like? Yeah, remove it. But you need to shift everything back down. Right? If 50 was here, 60 was here, etc. So just like when I inserted something, I shifted everything to make room for it. Now I need to shift everything down. Right? Do I need to worry about overriding anything? Remember, what did I remove here? 30, right? Well, I saved 30 off into this temporary variable, right? So that I don't need to worry about that. I can just go ahead and work left to right, shifting things down, shifting things down, shifting things down. A more traditional for loop here then. For int I equals, I started index, I is less than something, I plus plus. This dot array sub I is equal to this dot array sub I plus 1. It's just the opposite as up here where I shifted everything to the right. Right? This is just reversed. Right? What do I go up to here? This dot size? Yeah. Well, let's figure it out. So 10, 20, 30, 40, 50. I start, actually, do I need to start at I? Index. Oh, I guess it's I plus 1. So move. Do I need to, whatever this is right here, do I need to move that? No, so it's going to actually be -1 at least, at the very least. Yeah, because -2, because it's strictly less than. Right. There we go. That all looks good. I can't do null. That was just my joke. All right. All right, so there we go. Save it off, shift everything down, return. Are we done? So if there are 5 things before, you removed them, you shifted down. How many things are there now? This dot size, minus, minus. Okay. All right, good. Let's just ad hoc test these really quick. What is my current state of my, there we go. System.out.print. Actually, let's go ahead and cut and paste this. And let's go ahead and say list.replace the element at index 2 with 99. There we go. So index 2 would of course be 0, 1, 2. So 30 then gets replaced with 99. Looks like it works. But of course, I would probably want to put this into a loop. Test it for 0. Does 10 get replaced with 99? Yep, it looks like it. Right. Does 42 get replaced with 99? Looks like it does. If you go out of bounds, do you get the exception that you expect? Yep. Right. You'd want to test all of these things. Not only that, would you want to test replace, but you'd want to test remove. List.remove, I don't know, 2. So it's getting kind of ugly because we don't have separators here. So let's put separators in here, put separators in here, there. So what should have been removed? 2, so 0, 1, 2, 30 gets removed, and 30 is gone. Let's try to remove the thing at 4, remove from the end. 99 should be gone, right? Et cetera, et cetera. Wait a second. Repeated code, repeated code. Printing out the contents of a list sounds like a blank thing. It belongs in the blank class. Fill in the blank there. So repeat it. Printing out the contents of a list sounds like a list thing. It belongs in the list class. Let's do it really quick. What should I call that function? ToString. Exactly. And what should it look like? String result. I'll start out with a bracket there, right? And then I'll go through a for loop and concatenate each element, right? And then I will put in an end bracket. And unfortunately, there is something that does this for you, kind of. Arrays.toString of this.array. Yes, you can use that, but what's it going to end up looking like over here? Oops, I didn't actually do it. Let's go ahead and go with system.out.println of list. Replace that. Replace that. There we go. It doesn't look right. Why? It's printing out the entire array. It only knows about the length of the array, the capacity, not the actual size. So when you're an engineer and has somebody already solved this? Yeah, they've solved it, but they didn't solve it in the way that I need to. Okay, now I've got to put on my gloves and I got to get my hands dirty. And now I do need to implement this to do. Next time.